What's up, guys? So, I've had an idea. What if you can tell what a certain liquid is just based on the resistance between two probes that you put into the liquid? So, for this test, I'm going to be using a multimeter as well as a soil moisture sensor. That will be the sensor I'll be using. And I'm going to have 4 cups, and one of them will be apple juice, another one will be cranberry juice and pineapple juice, and finally the fourth will be a control, water. So I will hook up the leads of my multimeter up to the leads of the soil moisture sensor itself, not the board, just the sensor itself. I'm going to hook these onto the leads, and then what we're going to do is measure the resistance and how much it varies based on what liquid we have it placed in. Let's go. Okay, so I have my multimeter set up here, and you're going to want to set it to the 200 kiloohm range. And like I said, I just have the soil moisture sensor connected directly up to the leads of the multimeter. So now I'll bring the 4 liquids. Alright, so first up we have the water. Then we have the apple juice, cranberry juice, and the pineapple juice. Alright, so what I'm going to do is turn on the multimeter, and remember it's set in the 200K range, and now I'm going to place the soil moisture sensor in the water first, and it is completely submerged, only the soil moisture sensor though.
Here we go.
We'll wait for it to stabilize, and we'll come back in about 10 minutes. Okay, so it's been about 10 minutes, and the reading has stabilized a lot more now. It seems to be hanging out around 28 kiloohms. So now I'm going to put the leads into apple juice now, and we'll see if the reading is any different. Hopefully it will be. Alright, well, the reading has definitely stabilized now after like 10 minutes again, and wow, it is very different than the resistance in water. The resistance in the water was like 30 kiloohms, and the resistance in this apple juice is only 7. So that is good. At this rate, I will be able to tell which liquid the probe has been stuck into just based on the resistance, because that's a drastic difference. Alright, let's shake it off. Now let's test out the cranberry juice. We'll just put it in once again, shake it around a little bit. And we wait. Alright, so this has stabilized now as well, and still less resistance than even the apple juice, so we should be able to differentiate between those two as well. Let's do the pineapple juice now. Alright, now we'll put it in the pineapple juice. Shake it around a little bit. Well, it's been a while, and the resistance does seem to be stabilizing a little bit. Regardless, though, all 4 different liquids do seem to have pretty specific resistances. So what I'm going to do now is create a code to run on the Arduino Uno, and it will process the values that the water sensor is sending, and it will analyze that, and it will print in the serial monitor what the probe is put into, and we'll see just how accurate that is. Alright, so this is all that we're going to need for this project, and we first connect the sensor itself to the board that it came with. You just connect it to those 2 right there. And now you have to connect this board up to the Arduino. So let's connect ground on the board to ground on the Arduino. Connect VCC on the board to 5 volts on the Arduino. Connect A0 on the board to A0 on the Arduino. Okay, so that is all the wiring that we need to do. So now we just program the Arduino with the code that I created for this project. Like usual, there is a link down in the description to my GitHub where you can download this code for yourself and you can try it out. So once the program is uploaded to the Arduino and you power it on, you must have it plugged into your computer with a serial monitor open. Okay, so I have the Arduino IDE pulled up on my computer screen here, and I have the Arduino plugged into my computer, and I have it way zoomed in on the computer, so I'm gonna just open the serial monitor here, and there it is saying that nothing is detected. So now I'm going to place the pineapple juice here, and I'm going to put the probe into it, and let's hope it is accurate. So you have to wait for the reading, and let's see here. So I zoomed out a bit there, and there it is, the pineapple juice. It started to display other things at first, but you just wait a little bit longer, and there it is. Perfect. Let's take it out, and let's dry it off first before we put it into the next liquid. Alright, here is the apple juice. Let's put the probe into that. Okay, now it thinks it's pineapple juice. It's kind of fluctuating back and forth between pineapple juice and apple juice. So, you know, not too accurate. At least it knows it's not water. Let's put it into cranberry juice now. So make sure to dry it off. And now, cranberry juice, we'll put it into that. Well, it thinks it's apple juice now. And it's actually cranberry juice. Well, I guess this project was sort of a fail, but at least you can can try it out for yourself and modify the code, and maybe you can get it more precise than I did. Alright guys, well, if you want to try out that code for yourself, you can download it from the link in my description to my GitHub, just like usual. And I hope you enjoyed watching this video. I guess it would be classified as a fail because it really just changed the values as it progressed on. But, you know, we tried. And you can modify the code however you want to, possibly by making the ranges smaller. You could have a longer wait time, and then it could end up making the measurement more accurate. I don't know. Pretty interesting. Hope you enjoyed watching this video, because I certainly enjoyed making it. And if you want to see more like this, go ahead and press that subscribe button and like the video. Thanks for watching, guys. Bye.